choosing which big data and machine learning products are the right mix for your solution is a critical skill that you have to learn. Later on in this module, you will get the opportunity to examine the architecture that real Google Cloud customers use so that they can serve as inspiration. Let's review the options available to you for compute and storage services so that you can better interpret those use cases later. The service that might be the most familiar to newcomers is Compute Engine, which lets you run virtual machines on demand in the cloud. It's Google Cloud's Infrastructure as a Service, or IaaS, solution. It provides maximum flexibility for people who prefer to manage server instances themselves. GKE, Google Kubernetes Engine, is different. Where Compute Engine is about individual machines running native code, GKE is about clusters of machines running containers. Containers have code packaged up with all its dependencies. So GKE enables you to run containerized applications in a cloud environment that Google manages for you under your administrative control. Containerization is a way to package code that's designed to be highly portable and to use resources very efficiently. Since most use cases involve multiple programs that need to execute and communicate with each other, you need a way to orchestrate the containers running these separate programs. That's what Kubernetes does. Kubernetes is a way to orchestrate code that's running in containers. Although Kubernetes and GKE are outside the scope of this course, I'll link to our cloud architecture specializations in the course resources. App Engine is GCP's fully managed Platform as a Service, or PaaS, framework. That means it's a way to run code in the cloud without having to worry about infrastructure. You just focus on your code and let Google deal with all the provisioning and resource management. You can learn a lot more about App Engine in the specialization Developing Applications in Google Cloud Platform. Cloud Functions is a completely serverless execution environment, or functions as a service, FaaS. It executes your code in response to events, whether those events occur once a day or many times a second. Google scales resources as required, but you only pay for the service while your code runs. So what's the difference between App Engine and Cloud Functions? Typically, App Engine is used for long-lived web applications that can auto-scale to millions to billions of users. Cloud Functions are used for code that's triggered by an event, such as a new file hitting cloud storage. The fastest way to lift and shift your data workloads is by provisioning a VM and running your code. You'll experiment with this later on when you run Spark ML jobs on Cloud Dataproc, which spins up Compute Engine instances for your cluster. Most applications need a database of some kind. If you've built a cloud application, you can install and run your own database for it on a virtual machine in Compute Engine. You simply start up the virtual machine, install your database engine, and set it up, just like in a data center. Alternatively, you can use Google's fully managed database and storage services. What all these, Bigtable, Cloud Storage, Cloud SQL, Spanner, Datastore, what all these have in common is that they reduce the work it takes to store different kinds of data. GCP offers relational and non-relational databases and worldwide object storage. You will learn more about these later on in this course. GCP also offers fully managed big data and machine learning services. Just as with storage and database services, you could build and implement these services yourself, but why manage the infrastructure for compute and storage when it can be fully managed by Google Cloud? Here's a complete list of big data and ML products organized by where you would likely find them in a typical data processing workload. On the left, you will see the foundation to where your raw data is stored. If your data isn't stored on GCP yet, you can ingest it using the tools that you see next. After your data is on GCP, you can analyze it using the tools in the third column and run machine learning on it with the tools in the fourth column. The last column is how you can serve out your data and ML insights out to your users.